Hello guys, welcome on Tesla Adventures. In this video, you can see the scenario that there is some liquid filled in a U-tube and initially this liquid was at rest. So if this liquid was at rest initially, so obviously according to the Pascal's law, the height of liquid level on the both arms, in the both arms will be same. And let us suppose that that height is h. So first of all, let us see that at this point, let us see that obviously due to accelerating this tube, the liquid will rise up in this limb, and let us suppose that it rise up by a distance of x. So it would descend down by a distance of x in this forward limb. Okay, because obviously volume will be conserved. The amount of volume which is descended in this arm will be the amount of volume which is ascended in this arm. So at this point A and at this point B, let us write down the pressures. So PA will be equal to P naught plus X plus H rho G, and PB will be equal to P naught plus this height will be H minus X. So it would be H minus X rho G. And obviously due to the fact that liquid is accelerating in the forward direction, the pressure at A and B will not be equal, and hence we can write down the difference between A and B, pressure difference between A and B by X equation. So it would be PA minus PB will be equal to L rho A, because pseudo force acting in the x direction in backward side would be MA. So G effective in this direction is A. So this will be PA minus PB. So PA minus PB will be 2x into rho G. You can see that. This is 2x rho G will be equal to L rho A. Okay. So cancelling this rho with rho, x will be equal to LA by 2g. So this is the value of x. And let us also solve this question by a second method, which is comparatively easier. So if we assume that if this point and this point, if we see the pressure at this point, then it would be P naught, and the pressure at this point will be P naught. So we can say that these 2 points lie on a equipressure line. So this is a equipressure line, and this line contains both of these points. Okay, so this is the equipressure line, and obviously this angle, this one is theta, and we know that tan theta is equal to A by G. This tan theta is A by G, and this is also x. So you can say that tan theta is 2x upon L, and x will be equal to LA by 2g. This is the value of x. Okay, so this is the simplest method. You can see that the answer came in just 2 lines. So let us take different scenario. Now in this scenario, you can see that the area of cross section of both the arms of the tube is different. So in this case, the amount of liquid, the height ascended by the liquid in this arm and the height descended by the liquid in this arm would be different. So let us assume that height ascended by the liquid in this arm is x1 and the height descended by the liquid in this arm is x2. Okay, and the original level of liquid was h. Now I know that some of you will be wondering that originally the liquid would be at different levels when the tube was at rest in the both arms. This is absolutely incorrect. So we have already studied the hydrostatic paradox, and we have already discussed the Pascal's law in that, and we again can see that when the tube will be at rest, then also the height of liquid level in both the arms will be same, irrespective of the fact that area of cross section of both the limbs is different. But the height would be same because in equilibrium, liquid will not flow from this point to this point. Hence, the pressure at this point and this point would be equal, and hence the height of liquid column above this point and above this point would be same. So this is very simple and clear. Now this liquid which is ascended by a distance of x1 in this arm, and it descends by a distance of x2 in this arm. So we can say that let us solve this by the easier method, that is by the equipressure line method. So let us draw the equipressure line. This is our equipressure line, and the pressure at these 2 points is P0 obviously. So this angle is theta. So we can say that the tan theta will be equal to A by G, and again tan theta will be equal to x1 plus x2 by L. So x1 plus x2 will be equal to LA by G. So this is the first equation. But you can see that obviously there are two variables in this equation, so we have to establish another equation also. So we know that the amount of volume of liquid that has ascended in this arm will be exactly equal to the amount of volume of liquid which has been descended in this arm. Because obviously liquid is ideal, it is not compressible, and density is constant. So we can say that obviously the amount of volume that has ascended in this arm is A1 x1, and the amount of volume that descends in this arm is A2 x2. So A1 x1 will be equal to A2 x2, and by substituting the value of x1 and x2, now x1 upon x2 will be equal to A2 by A1, and by substituting the value of x1 and x2, x1 will be A1 LA by G upon A1 plus A2. This will be in fact x2, sorry, and x1 will be equal to A2 LA by G into A1 plus A2. So this will be the height of liquid columns in both ascended and descended in both the arms. Thank you.